In the last video, we have here the following equations and you were asked to solve them. So here are the solution of the following equations. Reminder, this is just only one of the many ways of solving these solutions. So for number 1, which is 2x plus 3y equals 10, we're just going to go the usual way that we would have. That is transposing the one that is a little more further on the right to the other side of the equation, which would mean we would now have 2x is equal to 10 minus 3y. Dividing both sides by 2, we will now be getting x is equal to 10 minus 3y over 2. And now we see that our y is our free variable. Therefore, we can let y be equal to our t being an element of the set of real numbers, and our x be equal to 10 minus 3t over 2. And this is the solution of the first equation. So now let's go for number 2, which is 3x sub 1 plus 4x sub 2 minus 4x sub 3 equals 0. So I can actually transpose to the other side any of the terms as long as I leave 1. So in this case, I'm going to transpose the first and the third one. So I will have 4x sub 2 is equal to negative 3x sub 1 plus 4x sub 3. Dividing both sides by 4. Wait a moment. We don't have space, so we're going to lift that up a little bit. There you go. We would now be having x sub 2 is equal to negative 3x sub 1 plus 4x sub 3 all over 4, which means x sub 1 and x sub 3 are our free variables. So therefore, we can have x sub 1 is equal to, let's say, another variable because we already used the number 1, let's say a, as an element of the set of real numbers, x sub 3 to be b. B can also be an element of the set of real numbers, while x sub 2 would be equal to negative 3a plus 4b all over 4. It is better if we would represent first the free variables because they are the ones used in the parametric equation. So in the last one, number 3, which I'll be writing here, we have 5x sub 1 minus 10x sub 2 plus 3x sub 3 equals 24. I would now like to transpose the first 2 to the other side. So therefore, I will now have 3x sub 3 is equal to 24 minus 5x sub 1 plus 10x sub 2. Dividing both sides by 3, I will now have x sub 3 is equal to 24 minus 5x sub 1 plus 10x sub 2 all over 3. Oops, we don't have space. So let's pull that up again. There you go. Now, we can see that x sub 1 and x sub 2 are our free variables. So we can let x sub 1 be equal to c. C is an element of the set of real numbers. X sub 2 be equal to d. D is an element of the set of real numbers. And x sub 3 is equal to 24 minus 5c plus 10d all over 3. So there you go. So those are the different solutions of our different linear equations. However, we don't just solve one specific linear equation. In many applications, we have to solve more than one. And if we have to solve more than one system of linear equation, we're not talking about systems of linear equations. So a system of m linear equations in n variables is a set of m equations, each of which is linear in the same n variables. So here is an example, a general form, and a solution of a system of linear equations is a sequence of numbers s sub 1, s sub 2, s sub 3 up until s sub n that is a solution to each of the linear equations in the system. So the most common that we have encountered is actually a system of linear equations, which usually I would shorten as SLE. SL is in two variables. And usually we would encounter a system of two linear equations in two variables. So this was actually the M and this is the N in the definition. And usually you would encounter some things like x plus y equals 2, x minus y equals 3, and we were asked, most probably in high school, to solve what are the values of x and y. So we are going to expound that because we cannot just have two, we can have a lot of equations. But first, we need to review how do we solve systems of two linear equations in two variables. So we have here three systems, and actually what we can do, if you would remember in high school, we have two ways of solving a system of linear equation. Usually either by elimination or substitution. So there. It actually depends upon the system and actually the solver of which one is easier. For number one, we have x plus y equals 3 and x minus y equals negative 1. Elimination is actually quite easier because if I'm going to add the two equations, y gets eliminated. And I will have here 2x equals 2. Divide both sides by 2, I will have x equals 1. Then I would go back to any of the equations. I'll just have x plus y equals 3, so I'll have x is equal to 1, so 1 plus y equals 3. Solve that, I will now have y equals 3 minus 1 and y equals 2. So therefore, my solution would be x equals 1, y equals 2. And that should both satisfy the two equations. And we know that 1 plus 2 equals 3, so that satisfies this equation. And 1 minus 2 equals negative 1, which also satisfies the second equation. Hence, our solution is true. So, using elimination, you can actually have substitution wherein, for example, I can have x plus y equals 3, x minus y equals negative 1. I will manipulate can be the first equation, can be the second. I will have y is equal to 3 minus x, and this is what I will substitute here, and I will still get the same answer. So, solve equation systems 2 and 3, and we're going to see its solution in the next video.